So we have two exciting speakers coming up next. One is John Wallace, and the other is Chris Butcher, just in the corner here, who will be popping up shortly, both from TimeXTender, to speak about the case for process mining, how data scientists can dramatically improve business operations. So I'm going to head it over to you both.
Thank you. So my name is John Wallace. I work for Inverbis. This is a startup, Spanish startup. Don't be fooled by my name. I'm fully from Spain. It's a Spanish startup that does process mining software. And I'll get into that in a minute. My background is not as a data scientist. I'm a management consultant, let's say, by training. But I've worked for quite a few years in the IT software industry. And now I'm working with Inverbis and trying to develop process mining and in this difficult market. So today what we want to do is actually demonstrate how process mining works and how it can help organizations improve their operations. But since I'm a management consultant by training, there's a few slides at the beginning, sorry. I'll try to be quick. So what is process mining? Process mining is a discipline that actually extracts the data from corporate systems and gives you a representation of how processes are actually being executed in real life, right? So we go into the systems, we pull out the data, and we show you how your organization is actually doing the work they're supposed to be doing. Now there's this misconception that, or expectation that, processes which are normally in quality manuals or they're in, in BPMN diagrams here and there are being executed in a certain way. And what you find when you go into the data is that this is hardly ever true. So with these kinds of tools, we can visualize the processes. We can certainly, show the different paths that a process has taken during its execution. So there's never one single way to execute a process. There's always hundreds of paths that the process has taken. And these we call variants. So this is one thing we show you. We show the statistics about the behavior, how many processes that follow which path, and what's the percentage of processes that follow the right path, and all these kinds of things. You can drill down then and filter different situations, different scenarios to try and find the root cause of why things are not being done the way they're supposed to be done. You can compare executions of the same process between teams, between sites, between geographies, whatever you want. And you can define process KPIs to monitor these processes. So a lot of the time in business intelligence, we have all these KPIs that are mostly static. For example, they'll show you if an SLA is being fulfilled or not. But generally, they don't give you the information of why or where the problem is. So with a process perspective, with process KPIs, you can understand if certain segment of the process, certain activities, are not being fulfilled the way they're being fulfilled, and that's why you're missing your KPIs. And finally, they can provide you insights into the future behavior of this process. So generally, we have predictive capabilities to be able to predict if you're going to meet that SLA or not at a certain point. So what are the typical use cases for process mining? Well, the obvious one is process improvement. So identifying waste, repetitions, loops in the process, all these kinds of things so you can optimize that. It's a good tool in automation projects because many times you go into an automation project and you automate a certain process or certain steps of a process. And sometimes you find that these steps are not being executed in that way. They're not being executed all the time. Sometimes other things are executed that you hadn't, foreseen. So many times you don't get the ROI that you were expecting because you're not automating the right things, right? So here's where these tools are very useful. You can evaluate compliance. So if you have, defined process that for regulatory reasons or for whatever needs to be followed in a certain way, you can use these tools to actually compare the expected execution to what's really happened, and then find out if you're really following this protocol and complying with the process. You can, as I said before, predict future behaviors and take actions to mitigate them. You can enhance your monitoring capabilities with process-related KPIs. And finally, you can use them when you're doing, a systems migration or something like that, SAP or an ITSM tool, which are process-based and flow-based, et cetera. You can really understand how these flows, these processes are really working in your source systems, so that you don't have to migrate everything. You might find things that are not being used, obsolete flows, et cetera, et cetera. So you can investigate that before you actually go into the migration and save yourself some effort there. So how does it work? Well, it's based on a very simple, model. As you can see here, basically to be able to mine a process, you only need a unique identifier. We call it the trace ID. This is the ID that links all the events or the activities in a process together. Then you need an activity or an event, and then you need a timestamp. You can have one timestamp, and that works. But if you have two timestamps, then you can, sort of differentiate between process steps and transitions between steps, which in things like manufacturing, when you're doing lean work, et cetera, is very useful. And then you have your attributes, and attributes can be anything. They can be any kind of, situation, resource, methodology, anything that can impact the process, and that you can get from your systems, and that will help you, derive these insights from the process. So the more attributes you have, and the better insights we'll be able to get from the process. Now, this is deceptively simple. I mean, the structure of the model behind it is very simple. But in reality, this gets very complicated, because generally systems are not designed to just give you this information like that, right? And this becomes especially complicated when you have a process that crosses different systems. So if you have a process that starts in your CRM and goes through, a logistics system and then ends up in an ERP or something like that, getting that information and reconstructing the end-to-end process is not easy at all. So that's the challenge, how to first access the data that comes from a variety of data sources, et cetera, and then how to build, a coherent representation of how the process goes through the different systems. So, for example, an order can be taken in your CRM system, that can be in the cloud, for example. Then when you have to produce that order, you have to go through a manufacturing execution system. That might be, a bespoke development or something like that. Then if you're going to ship that, you go through a logistics system. And finally, for invoicing and accounts receivables, et cetera, it ends up in an ERP. So if you want to track the whole thing, you have to get the data from all these different sources. And sometimes you have to transform it. So you have to, link the different unique identifiers, or even create, in some cases, an identifier for the whole process. And you have to filter activities out, et cetera, et cetera. And this is where, TimeXTender becomes an invaluable tool when you're in this situation, because it allows you to actually access a wide variety of sources. It allows you to, in a very easy way, transform and compound the data and filter and compose the data to create this coherent trace, and then it can be then loaded into the process mining tool. And here we're partners with TimeXTender. We have reached an agreement with there, and we created a connection between the TimeXTender platform and ours, so that this can be done in a very easy and seamless way. So now I'm going to give it over to Chris, who's going to explain you a little bit of context about TimeXTender and how this process works in reality.
Cheers, man. Thank you. Okay, let's hope this works. Okay. Let Let's start with a very sweeping statement, okay? The modern data stack, as we've all come to know it, as John sort of alluded to earlier on, we start off with the files, and we have to get that into some semblance. We have to merge that all together, and this is what TimeXTender is all about. So we're starting off with multiple different data sources, multiple different files. We're moving that through different transformation steps, different scripting. And at that point, we have to go back and document it, and then we may have to start again and move through. And these processes can become very complex. They're very time-consuming. They can be expensive with large teams of processing and developers. And you get a lot of tools moving about in there. Excuse me. So wouldn't it be great if we could find something that brings all that together in a holistic solution? And that's what we've sort of done with TimeXTender. And a little bit about TimeXTender for those guys who've not heard about it, which is probably most of you in here probably. We've been about since 2006, which is we were formed the same year as Microsoft Analytics Services was brought into being. So we've been around quite a long time. We've been quite a good kept secret in the community. We've got over 3,500 customers, and we're 100% partner driven, with Inverbis being one of our major partners, and that's why we're here helping these guys out. And we're in about 90 countries worldwide. So what is TimeXTender? Come on. TimeXTender. We are a data estate automation company. We give you access to over 250 individual data sources. These are REST APIs, web connectors and things like that. We can then take those APIs, take the data from those APIs and move them into a data lake, a structured data lake of your choice, whether it be AWS, whether it be Azure. And that ingestion, it gives you that data in one format. Okay, at this point we can move that out. The data scientists can hit it from that point, or we can then move it into a preparation area. So we can move it into a modern data warehouse. Again, we can do that in AWS, Azure, Snowflake, so we can keep up with the latest trends and technologies. Okay, once we've got all the data normalized and consolidated and we've done some coding on that, we can then move it through to the delivery phase. This is where we use a shared semantic model. Okay, this is where the business logic comes through. This is where we try and get the data through to the business logic as fast as we can. And at this point, we can deliver that data out to process mining tools. We can deliver that data out to your guys' choice of visualization tool as we're moving it forward. And with TimeXTender, we do it full documentation, full data lineage, and with intelligent execution. Okay, so how does that fit into the Inverbis model that we're going to be looking at today? Okay, so we're going to break down the silos. So as we sit in the data flow through Inverbis, we take the unstructured data sources. Okay, we then put them into our, what we call the ODX, which is our operational data exchange. Okay, this is where the different sources, we're connected to the ODX and we can access them when we need them. We then move it through to the MDW, which is our modern data warehouse. So we do some filtering, we can do some merging, and then we put it through to a semantic model. Okay, and then that data is generated within Inverbis, and then it can be fed back into TimeXTender through some scripts. So we're going to push it out into Inverbis, then it can come back if we need it to come back into there. Then at that point, we can take that out and we can push it into Click or Tableau or whatever you want to do some Power BI modeling. Okay. Let's get out of here. What they always say is, never do a live demo, but I am that soldier, so here we go. So what we have in TimeXTender, oh, come on, not Click. AWS. Hang on. Never do a live demo. Go away. Oh, that's good. TimeXTender. Don't want Click, but never mind. What? Guys. This is really going well, you can tell that. What the heck is happening? Anyway, we'll try and get through this. We'll go straight into TimeXTender. Okay, TimeXTender is two pieces. There's two parts to TimeXTender. There's a web interface where we can create all the connections. We can create all the connections. It's all working. Go away. You notice I'm not getting flustered or anything. I'm doing this really... Hey, there we go. Okay, right. So, two parts TimeXTender. As I said before, we've got multiple data sources. We give you access to these data sources and we configure them in the cloud so they're available to multiple instances of TimeXTender. Okay, we have data sources. We're moving through here. We have SQL data sources we can use as your data factory. We've got Oracle. We've got some REST connectors in here, and these have all been previously configured. So what I'm going to do, I'm going to jump into TimeXTender, and we're just going to go through the process of bringing some data in, quickly consolidating it, moving it out, and running it through a little bit of scripting so we can transfer it over to Inverbis so John can move it forward from there. Okay, so as we've said before, this is sort of TimeXTender. Our initial piece is our ODX, which is our Operational Data Exchange. So what I'm going to do in here, I'm just going to add a quick data source. Okay, and we're going to call this process. Okay, and go to next. Then I can select from the previously configured data sources that I've got done. So I'm just going to do a Glasgow one. I'm going to pull some information in from a SQL. Software's asking me, do you want to pull all the tables in? I do, but I'm not going to do. I'm going to just cherry pick some out of the initial data source. So the software's gone away. It's reading the data source, and it's going to come back and it's going to allow me to have a read-only access to that data source. So at this point, what I can do, I can go through and I can pick out the tables that I want. Now, I know my production model in here is the stuff that I need to put into my process mining system. So I'm just going to add that file, add that table. At this point, I can look at the table. So I can preview, and I can run some code against it. So I can see, okay, this is what I need in that table. This is the information that I'm looking for. So we can come through here. In here, we have some start dates, some end dates. We may have some IDs and stuff in there that we're going to use in the process mining model. What I can also do is include or exclude the columns that I want to pull in. So I can load the information into that table. This is all read-only, so you can do this without giving access to the back office systems. At this point, I can add and remove columns as I want to. Okay, so I've selected my table. We're going to go to next, and it's going to ask me, do I want to create a transfer task? So yeah, I'm going to create a transfer task because TimeXTender, we all work in meta. So what I'm doing at the moment, I've told the metadata what I want to do, but now I'm going to create a task to transfer it across. So we'll call it get data. And we go to next and finish, and we'll just execute that. TimeXtender's gone away. It's now pulling data into the data lake into a single format that I can use. Once it transferred it across, it's now completed successfully. I can now do a quick refresh. And I've now got access to my new process system over here. So this is my data lake. This is a view of my data lake. I can search my data lake, and I can see the new file that's brought it in for me. What I can do from here, I can now start merging the data together using TimeXtender's UI. So what I'm going to do, I'm going to pull that data into and over my existing process model. Okay, what TimeXtender's come up with, okay, it's telling me now, okay, you've got two models in there, you've got two mappings against that field. So I can look in here, and I can see my two mappings I've got. What I've also got, what it's also telling me is, okay, there's two fields that I'm not quite sure about. Okay, so I can look down here. If I highlight the new process that's come in, if I move across to the left-hand side, I can see in the fields down here that it's telling me where the mappings aren't lining up. So what I can do with TimeXtender is highlight my new fields and just pull in. Okay, it's my size, hover it over the top, add it. Now I've got 2 mappings against that field. What I can do from here, I've got the weight one as well. I can bring that in. Notice that it won't let me add the field. Just drop it in over the top. So I've now got my 2 mappings. Okay, that table's now ready. It's all merged together. It's a lot happier than it was before. What I can do now, I can deploy and execute it. Deployed and executed. We go to version control. We can add a version as we need to go. So this is just creating the table. Now it's doing the information, creating the table from the metadata. There we go. It's just finished. Cool. Close out of that. Now we're ready. We've merged the data together. We've pulled the data across. We've put it into the script. What we can do now is transfer that directly into Inverbis. So we've created it. We've created a data model. We've got a data model above that. So what I can do here, I can now deploy and execute it and move the data ready to go across and give it a version control name. Quick save. The data is now available to John. So now I can pass it back over to John, and John will have some information ready to go. That's right.
Now, how can I show my screen here? As you can see, I'm the tech guy. Which is Control? Ah, wait, it's...
Where before? Go.
No? Oh. Ah.
There you go. Duplicate.
Yeah.
Gotcha.
Great. As Chris said, never do live demos. Right. Okay, so hopefully this made sense to you, and you know, it showed you how easy it is to get data from different sources and process it so that we have that simple yet elusive data model that we need for process mining, right? So now the data has been passed into process mining when Chris run the script. We have here, as you can see, these are data sets. We have here, as you can see, Telco TimeXTender, which has been data that has been brought in from TimeXTender. I'm actually going to use this one because I have some, in order to be quicker, I have some filters already created in this data set, but it's the same data. So I'm going to click there on the data set, and this is the first screen you see when you go into Inverbis. Now, what is it that I'm going to show in here? So this is a customer service process from a telco operator. This is demo data, but it's based on an actual case that we did for a client. So it's pretty close in terms of what the process is. And what this has done is the telco client had a CRM, which had the customer service requests and everything like that, and the call center people used it, et cetera. But whenever, the fault or, the request required a field service activity, so you had to send a technician to the client's premises to do something, they have a different system, which is the field service management system, where they logged all that. So what we've done here using TimeXTender is we combine those two sources, the CRM with the field service management system, to create, one single view of the process, not just the customer service call center side of it, but whenever that has to go into field service, then we can see the whole process end to end. So when we go into the tool, the first thing that you see is the most executed version of the process. Now, this is a pretty simple flow, as you can see. We have, let's see if I can maybe make it a little bit bigger. You can see it. So we have, a new service request is created. It's assigned to someone. They're in progress solving it. It's solved and it's closed. So if it can be solved online, this would be the process, the happy path, let's call it, that they would follow, right? Now here, I've done something with there. So now here on the left-hand side, you have the basic information about the data set. So we have 4,933 cases that have gone through the system in this period of time. We have 17 variants. That means the process is being executed in 17 different ways. This is demo data. In reality, when you do this with real data, you get hundreds or even thousands of variants. The average duration has been 2 days and 11 hours, and this is the range of dates that's in the data set. Here you have the same information that you will see for each flow that's being shown here in the tool. So basically the same information. And here we can actually aggregate these 17 variants as we want. So we can aggregate, 5 variants, for example, and we can see how the process looks if we combine, the first 5 ways of executing it. And you can go all the way until, all the 17 in this case. And as you can see, this becomes quite complicated. So this is what we call the spaghetti in real life. When you have hundreds of variants, it's just completely unmanageable, right? So the other thing we can do here is what you're seeing right now here is the flow of the process, the number of executions. So this is 2,168 have gone through the process. I can switch this to duration, and then I can see the duration of the different steps. So 30 seconds to create it, 1 minute to assign it, 5 minutes in progress, and then solved, etc. Or I can show both, the flow, the number of executions, and I can also show the times here. So now that we've seen we've got 17 variants, let's see if we can look at them, individually. So if I click on variant browser, here I have the different variants ordered by a number of executions. This is the first one, obviously, 43% of the times it has gone through here. But if I click on the second one, I get a different view. And here what I get is the flow when you actually have to create a work order and have a field service intervention after it. So new assigned in progress couldn't be resolved online in the call center. So they opened the work order. That work order is scheduled, it's confirmed. The field service people go and execute the work order, they close it, and then the service request is closed and the process ends, right? So this would be what we would probably call the happy path when there needs to be a field service intervention. But I can keep on going through the variants. So if I click on number 2, now I start seeing, stranger things. Here I see a loop, right? So it's assigned, it's in progress. They give it a solved, but then it has to be assigned again. So this is a reopening loop. It wasn't really solved, and it has to be assigned again, and then it goes back through the process. Eventually, a work order needs to be created, and it goes through the field service loop, right? So this, which I've seen on variant 3, I can actually see for the whole data set with the loop inspector. So what this will do is it will show me all the loops that I have in the data set, list them here, as you can see, in order of execution. So this one, the reopening loop we just saw, has happened 7.5% of the times. But if I click on the second loop, which is this one, the second most executed loop, this one, the actual work order was opened, it was scheduled, but then instead of being confirmed, it was executed. The field service team went to execute it there. And obviously, since they hadn't confirmed the visit, something happened, no one was home or whatever, they had to go back, reschedule the intervention, then go through the confirmation loop and then go through it. So we found here an instance where, because they didn't confirm initially, they had to go back and so on. Now, what I can also do here is start analyzing how these processes are actually performing. So the first thing I can do, for example, is I can go through and find out, this is what I told you about. We have a filtering, extensive set of filtering capabilities here. So we have filters by activities. So it's by start activity, by end activity, by occurring and non-occurring activities, which is interesting most of the time. Arcs, which are the transitions between the activities. So I can look for occurring arcs or non-occurring arcs and filter through them. The attributes, all the attributes that you have in the data set, in whichever format, numerical, textual, Boolean, or date and time attributes. And then I have date and time filters, so cases that start before a certain date or end after a certain date or whatever, and duration filters, both for the whole case duration, for activity duration, or for arc or transition durations, right? So these filters I can apply to the data set, and I can also save in filter sets, and this is where I have this one. So let's say I want to see which of my executions are actually fulfilling the SLA. So I can filter this here, right? And I've filtered for, first of all, I only have an SLA for cases that go into field service, right? And this SLA is 4 days. So I filtered, first thing I filtered just the cases that actually go into field service. So I'm actually comparing the right stuff. And then I put the filter that they take longer than 4 days, right? As you can see, the first thing that appears here is the one with the loop. So obviously, if I'm getting into loops, this will delay, the execution of the process and probably breach the SLA. But the interesting thing is, if I click on the variant browser here and I go to the second variant that has not met the SLA, it's actually the happy path, right? So even when I'm following the happy flow in 286 cases, you can see here, I'm actually not meeting the SLA. So why is this? So if I click on duration, I can see something interesting, which is between opening the work order and scheduling the work order, just getting, with the client to schedule, we have an average of 2 days for this variant for these 286 cases, right? Which is a lot of time, and if I have an SLA of 4 days, just waiting 2 days in scheduling the visit is probably going to make me not make the SLA, even when I'm actually running the happy flow. So I can also do something here, and let's reset the filters, and I can see how many of these cases are actually going through a scheduling process that takes more than 1 day. It shouldn't take more than 1 day to schedule the intervention. So I'm going to filter that. And as you can see now, I have also the happy path here with an average of 1 day. This is 870 times. But in the end, I have 36% of my cases are actually taking more than 1 day, not 2 days, but more than 1 day in scheduling. So I definitely have some room of improvement there that I can work with to optimize this process. Right. More things that I can do with this data. I can actually, now that I know this, I can create an alert. So if I click on the alert tabs, let's reset the filters. I can click on the alert tabs, and I can create a new alert, right? Set up new alert. I call it, let's call it scheduling. I'm going to give it a high priority. And what I can do is any of the filters that I've applied to the data set, which are generally conditions, I can apply here for the alert. So if I click on the filtering on the filter that I did of scheduling longer than 1 day, I can set that, and I can set an alert. I can set it to send an email to the user or to a different email, a generic inbox or whatever, or not to send it and just look at it in the tool. And I add the alert. So now I've got this alert here, and every time this condition is met, every time, bear in mind that this can have a frequency of update, whatever you want it to be. It can work up to almost real time. But if I'm looking at this, let's say daily, I can have my daily report, and I can have every time this condition is met, and I have this problem, it sends me an alert. Right? We can also do live conformance, which is what we talked about before, one of the use cases. What I've done here is I can load a BPMN model into the tool. So I've loaded this happy path model here, which is the happy path when there's field service. I'm going to filter here just for field service cases. Sorry, I got a filter set here. I'm going to filter just for those so that I'm comparing apples with apples. So now that I've got it filtered, I go to live conformance, and here it's comparing all the executions with that model there, with the happy flow. And I can see that only 65% of the cases conform to that model. I can also see what the main nonconformities were. So I can see that certain transitions of activities don't conform to the model here. If I had any unexpected start activities, it would list them there, and unexpected end activities. Now this is not very fair because we have actually in this data set instances where the process has not finished yet. So obviously we would find traces that have not gotten to the end activity. And then we can look for these nonconformances associated to attributes. So the call center group, this is more related to a certain call center group, the nonconformances, or to call center location, or to a specific contractor of the field service, or to a type, for example, a type of service request, right? And here I can see which of these things impact the nonconformities more. And finally, we have some process metrics here, a basic sheet of process metrics for variance, activities and transitions, frequencies, longest durations, maximum, minimum duration, etc. This you can all export. And you have it for the activities too, which are the activities that take longer, etc., etc. And you have it for transitions in order to find the transitions, find where you have, say, bottlenecks. For example, here between assigned and solved, we've got 3 days duration, average duration. This seems like a lot. So you can track these things here. And finally, since we're running out of time, what do we do also with this data? And it's very easy to extract this data and process it, creating your own dashboards. Here I have one in Power BI because lots of our clients use Power BI and it's easy for us to make one. So what we do is we can customize these different dashboards for the data set and pull the data out there and show it in a Power BI dashboard. Now this could be combined with other KPIs that you have in your organization. If you're using Power BI, we can also do this with Click or with Tableau, with whatever, right? So here, what you have is basically, here we have the variance that we just showed in the tool. So you can actually go to a specific variant and see how that relates to the different attributes. For example, the call center, the result of the field service intervention, the group that attended the call in the call center, or the type of case, for example. So we have the average duration of the cases when there is field service up here, when they're solved in the call center. We have the SLA fulfillment here, and we have the average duration of the transition. So for example, the one we saw earlier about scheduling, taking too long to schedule. If I click here, obviously this is Power BI. I can see that Valencia is not doing such a good job here compared to Alcobendas, but especially I can see that the internet group is the one that's actually missing these scheduling calls or taking longer to schedule the calls. So here you can create this and you can configure it as you want, and it can be useful to track these types of things like the one I just mentioned. And then more interesting even for these types of processes, this is not for every process, for these types of processes, we have our predictions, right? So what we have here is the cases that are active, that have not yet finished, right? Where they are at, the latest performed activity, the predicted variant, and we have the current duration and the predicted duration. So what we're doing here is predicting the duration based on where they are, and we're giving it a, let's say, risk score of breaching the SLA. So if it's 0, it's on track to fulfilling the SLA. If it's 1, if it's 2, it's even worse. And if it's 3, there's no chance. Here you can see the X's here, places where they've already, gone gone over the SLA anyway, so it's impossible to meet it. So here you, based on these predictions of these 320 still active cases, you can have a view of what the prediction of fulfilling the SLA is. So you're on track to fulfilling the SLA in 90% of them, and there's 10% where you're not on track to fulfilling it. You can see where these are, in which state these cases are, and you can see the predicted durations of the ones that are still running. So with this, you can actually look at what's happening every day and take the measures that you need to be able to improve SLA completion, right? You can also set up alerts so that when something's not going to make it reach the SLA, it can alert you, etc. But you get the general idea. So this is how let's say you can help improve the operations, not just the bottom line or the top line in terms of your patterns or whatever, but the actual operations. You can give the organization a view of how the processes are really working, how the people are executing the work, so that they can take the necessary actions to be able to improve this. And that's all from my side.
Thanks, John and Chris from TimeXTender and Inverbis. For lunch, just as a heads up, if you find someone downstairs, a volunteer, if you have any vegan, vegetarian, gluten-free options, feel free to just take a scope out for them before eating. Have a great lunch and see you in the afternoon.